All right, class, welcome. Have you ever opened up a spreadsheet and just seen a wall of numbers? It's overwhelming, right? Well, today we're going to talk about how we can take that mess of data and actually find a simple, clear answer to a real-world question. And that really is the big question, isn't it? When you're faced with this giant sea of data, how do you pull out that one single answer you're looking for? It can feel, like you're searching for a needle in a haystack. Well, the secret isn't to just squint harder at the numbers. The answer is you draw a map. And for us in the world of data, that map is a chart. It's what we call data visualization. It's a way to turn all that confusing stuff into a picture our brains can understand in a flash. So for our quest today, we're going to use one of these maps to find a little bit of treasure, the cheapest pumpkin. Okay, so our mission is to draw a map, but before we jump in, let's take a step back. Why even bother with this? Why is visualizing data so incredibly important in the first place? It really boils down to a couple of key things. First, it just helps us get the data. We're visual creatures. We can see patterns and trends in a picture that we would completely miss if we were just looking at a table of numbers. And second, it makes it way, way easier to share what we found with other people. A good chart can tell a story all by itself.
All right, enough of the why. Let's get to the how. Let's start our great pumpkin quest and put this into practice.
So here's our mission, plain and simple. We want to know, when is the absolute cheapest time of year to buy a pumpkin here in the US? A pretty useful question to answer, right? Especially when fall rolls around. And here is the data we're going to be working with. We've got the month, and then the low, high, and average prices. Now, just take a second and look at this table. Can you instantly tell me which month is the cheapest? Not really. You could probably figure it out if you stared long enough, but it doesn't jump out at you. So this is our haystack. Let's start building that map to find our needle. Okay, time for our first attempt. Let's try to make our first map out of this data and see if we can find some clues. A pretty logical place to start, you might think, is to just take every single data point we have and plot it on a graph. Let's just see what we've got. The chart we use for this is called a scatter plot. So to set this up, we're going to put the price on the bottom, the horizontal x-axis, and on the side, the vertical y-axis, we'll put the month. So you'll see the number 8 for August all the way up to 12 for December. And there it is. So what are we looking at? Well, every single one of those little dots is one price report from our data. And right away, we can see a couple of things. We can see that all the sales are happening between month 8, August, and month 12, December. And wow, look at that price range. It's all over the place, from about $10 to almost 60. Okay, so let's get back to our main question. Looking at this big cloud of dots, can you confidently, quickly tell me which month is the cheapest? It's tough, right? I mean, it kind of looks like the dots in December are lower down, but it's really messy. It's not a clear answer. This particular map, it's not helping us very much. So yeah, that cloud of dots, it just isn't cutting it. We need a clearer answer. So it's time for a new strategy. Let's try to draw a better map using a different type of chart. Here's the new plan, and this is really the key. Instead of plotting every single little dot, we're going to simplify things. We're going to take all the prices for each month, calculate the average for that month, and then just plot those 5 average numbers. It's about cleaning up the noise. And check this out. This is the perfect example of why picking the right chart is so important. When we take these averages and pop them into a bar chart, bam, look at that. The answer is suddenly crystal clear. Each bar is a month, and how tall it is tells you the average price. All that guesswork is just gone. See? Now we have the right map. Now we can finally find our treasure. And just as important, we can start to understand the story the data is trying to tell us. And there it is, plain as day. We don't have to squint at a messy cloud of dots anymore. The answer is right there, you can't miss it. That little short bar on the far right tells us everything we need to know. December, that's our winner. It is by far the cheapest month to buy a pumpkin. But our new, better map also shows us the other side of the story, right? Look at those 2 tallest bars, September and October. They're way more expensive than the other months. And that should make you ask another question. Why? Why would they be so expensive then? Well, this is the cool part, where the data starts to connect to the real world. Think about it. What happens at the end of October in the US? Halloween, And that means there's a huge demand for pumpkins, for carving, and for decorations. When demand goes way up, prices go way up. It's just simple economics, and our chart proves it. So, let's wrap this up. What are the big takeaways here? First, visualizing your data is how you turn a confusing mess of numbers into a clear story. But second, and this is the most important lesson for today, choosing the right kind of chart is everything. It totally depends on what question you're trying to answer. The scatter plot, it was okay for seeing the whole range of data, but the bar chart, that was the perfect tool for comparing the averages and getting us that one simple answer we were looking for.
So think about what we did. We used data to find the what. December is the cheapest month. And we even figured out the why. It's all about Halloween demand. But this leads to an even cooler question, doesn't it? Could we take this same data and use it to predict what pumpkin prices will look like next year? And that, class, is where we're headed next in data science. We move from just understanding what happened in the past to predicting the future. Thanks for tuning in today.